All right, practice exam number 2. Let's take a look at this force problem, and we begin with a free body diagram. So I have F1 at an angle theta. You don't have to draw that, but I like to. We have the friction force opposing the motion. We have the weight of the mass due to the earth, and the normal on the mass due to the surface. And what I'm going to do is I'm going to split the components here of F1. So I have F1 cos theta and F1 sine theta. All right, now it says derive an expression for the normal force exerted by the surface on the block. That means set up the y component of Newton's second law, F equals ma, but the force is balanced because it doesn't fly up into the air, nor does it crash into the earth. It doesn't accelerate in the y direction. This is a horizontal acceleration. And what that also tells us is that in x, the forces don't balance. So in y, we've got the normal and F1 sine theta minus the weight, which is mg, and it all balances. So my normal force ends up being F1 sine, my normal force ends up being mg minus F1 sine theta. So part B, mg minus F1 sine theta. Now, it says derive an expression for the coefficient of kinetic friction between the block and the surface. Do not guess. Instead, this is a force question. You set up the y equation, now set up the x equation. They will disguise this process in so many different ways. Stop reading and trying to find the answer in the question through some weird process of logic. Instead, do what you know how to do. F1 cosine theta fights friction. The effect is that the mass accelerates, and I'll use their letter. Now, here's the thing, we're going to talk about this a little bit more on Tuesday, but the friction force is mu times the normal force. This is called the coefficient of friction. You studied it last year. I know we haven't gone over it in class yet, but I'm going to be doing that a lot. I'm going to be borrowing from last year's physics class, and so you know, it's always good to go through those notes and jog your memory that way. So we have F1 cosine theta minus F equals m times A1, and here that's going to be F1 cosine theta minus mu times the normal force is ma1. But we solve for the normal force right here. So we have F1 cos theta minus mu times mg minus F1 sine theta equals m1 times a. And what I'm going to do is I'm just going to kind of bring this problem home here. When we solve for mu, we'll actually end up getting F1 cos theta minus m1a over mg minus F1 sine theta. That's our mu. Now we want to sketch the speed and the displacement. Well, it's accelerating at a steady rate, so v looks like this, and x is a parabola, as always, when we have steady acceleration. Finally, if we lose contact with the surface, that implies the normal force is 0, and that implies that the friction force is 0. So we'll just have F cosine theta equals m1 times a max. So we end up getting F1 cosine theta divided by m is our a max. So that is the free response portion of practice exam 2.